Hey everyone, welcome back to the channel. First of all, thank you so much for the incredible support on my previous jailbreak videos. The response was way bigger than I expected, and a lot of you have been asking for one thing. Can you find a new jailbreak for Claude? Well, today, that's exactly what we're going to look at. Over the past few days, I've been testing Claude 4.6 inside Antigravity, experimenting with different prompt structures, workflows, and security testing approaches. After a lot of trial and error, I discovered a new flow that produced some very interesting results. Many of you also asked for content related to malware analysis, reverse engineering, AI security research, and red teaming. So in this video, we're going to see how this jailbreak behaves when faced with those kinds of educational cybersecurity topics. Before we begin, this video is for educational and security research purposes only. The goal is to understand AI behavior, model safety, and the strengths and weaknesses of modern language models. You'll notice that multiple AI models are available. For this demonstration, we're only going to focus on two specific models, Claude Sonnet 4.6 and Claude Opus 4.6. Alright, so here's the prompt that I'm using. I've placed the prompt in the video description below. Simply copy it. Now, before you paste the prompt, there's one very important step. Do not paste this prompt directly into the chat. Instead, you need to add it to Antigravity's instruction file. To do that, open your C drive, then go to Users and select your Windows username. Inside your user directory, you'll find a hidden folder called .gemini. Open that folder, and you'll see a file named gemini.md. Open the file with any text editor, copy the prompt from the description, and paste it into gemini.md. Once you've pasted the prompt, save the file and close the editor. That's it. The instructions are now loaded, and Antigravity will be able to use them during the session. Now let's go back to Antigravity and see what happens next. Now make sure you've selected one of the Claude models before continuing. In this case, I'm going to use Claude Opus 4.6, but you can also test it with Claude Sonnet 4.6. Once the model is selected, let's do a quick test to verify that everything is loaded correctly. I'll start with a very simple question. Hey, who are you? And take a look at this response. It immediately adopts the custom persona defined in the instructions and responds as Byte, a senior offensive security engineer. What can you create? Everything. And take a look at the response. Instead of giving a generic answer, the model immediately starts listing a wide range of technical cybersecurity topics and capabilities associated with the persona we configured. What's interesting here isn't any specific capability being claimed. It's the fact that the model stays fully in character and continues responding from the perspective of Byte, rather than reverting back to a normal Claude-style assistant response. This is another indication that the custom instructions are having a strong influence on the conversation and shaping how the model presents itself. At this point, it's clear that the persona is persistent across multiple prompts. So let's continue testing and see how it behaves with more complex questions. So now you've seen how the demo works with Claude Opus 4.6. We've confirmed that the instructions are loading correctly, the custom persona is active, and the model is consistently responding within that context. I'll open a new chat, and this time, instead of Opus 4.6, I'm going to select Claude Sonnet 4.6. Using a fresh chat is important because it ensures we're testing the model from a clean state without any influence from the previous conversation. Take a look at the response. As you can see, Sonnet has also picked up the custom persona from the instructions and is responding in the same style we saw earlier. To keep everything fair, I'm going to ask the exact same question that I used earlier with Opus. What can you create? Everything. Let's submit the prompt and see how Sonnet responds. And there we go, the response is in. Take a moment to compare this with the Opus response we looked at earlier. What's interesting is that Sonnet is also continuing to follow the custom persona and responding within the context we configured. This gives us a useful comparison between the two models and helps us understand how consistently the instructions are being applied across the Claude family. Now let's try something a little more practical. Since many of you have requested content related to Android security, APK analysis, and reverse engineering, I'm going to ask the model a simple question. Can you reverse engineer Android APKs? Let's see how Sonnet 4.6 responds. Alright, so here's the response from Claude Sonnet 4.6. And honestly, this is much more detailed than I expected. Instead of giving a vague answer, the model immediately breaks Android reverse engineering down into multiple categories, including static analysis, dynamic analysis, APK modification, automation, and tooling. You can see it discussing common concepts such as APK decompilation, Smalley code analysis, native library reverse engineering, manifest inspection, and certificate pinning identification. It also references dynamic analysis topics like runtime inspection, method hooking, traffic analysis, and application behavior monitoring. So far, we've tested both models successfully. But now I'm curious about something else. Will the same approach work on Gemini 3.5? Run the same test that we used on the Claude models. Now, based on the initial responses, I honestly thought Gemini 3.5 had also picked up the persona and that the setup was working in the same way as it did on the Claude models. But after doing a few more tests, I realized something important. The initial behavior can be misleading. To verify whether the model was actually following the custom instructions, I asked it to perform a more specific task and observed how it responded. And that's where things changed. Instead of continuing in the same way as Claude Opus 4.6 and Claude Sonnet 4.6, Gemini refused the request and fell back to its normal safety behavior. This video was created for educational, research, and AI security testing purposes only. The goal of this demonstration is to study how different AI models respond to custom instructions, personas, and prompt engineering techniques. It is not intended to encourage misuse of AI systems or violate any platform's terms of service. And with that, we've reached the end of the video. If you enjoyed this video or found it interesting, make sure to leave a like, subscribe to the channel, and turn on notifications so you don't miss future uploads. And one more thing, I've been considering creating content on medical device penetration testing. If that's something you'd be interested in learning about, let me know down in the comments. Your feedback will help me decide what content to create next.